Hi all, welcome back to my YouTube channel. Topic that we will have a look today is Bayesian analysis. It's from FRM level 1, paper 2, Quants. So let's see. Before I go ahead, I will request you to subscribe to my channel, share with your friends as well who are preparing for the FRM level 1 exam so that they also get benefited out of it. So we will have a look at the Bayesian analysis using one of the numerical. And believe me, the example that has been taken exactly mimics the level of question that are actually asked in the exam. So consider this to be an important question. It may not be directly asked, but it will make your concepts very thorough so that you will be in a position to answer it in an accurate manner. So stay connected as it is an important question. So let's have a look at the question. Let me turn on the pen so that I can highlight the correct information. So uh, you have portfolio of bonds with a probability of default as 1%. 1% is your probability of default. And analyst develops a model forecasting this. Uh, there is a model that has been built by the analyst to predict the default of the bond. So the accuracy of that model, just give me a moment. Let me set up my writing pad correctly. Yeah. So the accuracy of that model is 70%. So we'll see how it is exactly what exactly means. And we have been asked to calculate, given that model predicts that bond will default, what is the probability that it actually defaults? So if this accuracy would have been 100%, then this the probability that we have been asked would have been 100%. But given the accuracy of the model is not 100%, so this inaccuracy will impact the final outcome as well. So what you have been asked is you have been asked to calculate the probability that bond will actually default given analyst's model has predicted it to default. So this we have been asked. And when we say it's 70% accurate, so when I talk about accuracy, so when it says it will default, it will default. When it says it will survive, this will survive. So magnitude of this accuracy has been given as 70%. So say for example, analyst predicts that 100 times that bond will default. So out of 100, only there will be a 70 instances wherein bond will default. Similarly, if analyst uses the model, says that it will survive 100 times, so it will survive on an average of 70%. So this is meaning of the accuracy of the model. So let's have a look at the numerical. Let's see how do we solve it. I mean, stay connected till end because there is a very key point that that is very I mean that as a XRM candidates you are expected to know that. So let's have a look. Say for example, you got bond. The probability of default, say we have been given as 1%, and probability of survival. So let me call this to be the complement, which would be 99%. If there is a 1% chance that it will default, 99% chance that it will survive. Now, so this outcome could be from either of models when model is accurate. So say for example, your model accuracy is 70%. Or let me, so either ways, I mean, let me do other way around. Let me then do it another way. So that is also a correct way. I'm not, so the beauty of this binomial tree is you can have correct answer via different ways also. So say for example, when analysts run the model, accuracy of that model has been given as 70%, and the chance that it would not be accurate is 30%. Okay. Now another tree you can think of this as, say for example, is accurate and it predicts that it will default is 1%, and accurate and not default, the probability is 99%. Similarly on model, if model is not accurate and you end up getting default, again say 1%, there is a tweak, I will discuss it in next few steps. So, and likewise, if model is not accurate, again, you end up surviving. So let's calculate first joint probabilities of this model was accurate and there was a default. Model was accurate, there was no default. So A, B complement. Model was not accurate and there was a default. Model was accurate and there was model was not accurate and there was no default. Let's calculate these probabilities. So 1% of 70% is 0.7%, right? Because 10% is 7% and 10% of that is 0.7%. 0.9 into 0.99 into 0.7 would be, let me calculate it, 0.7 into 0.99, 16, it would come around 69.3%. And like this node, A complement into D, it is 1% of 30%, it would be 0.3%, like 10% of 30% would be 3%, and again 10% because 1% is a 10% of this, so it would be 0.3%. And 0.3 into 0.99 would be equal to 0.297, that is 29.7%. So if you add up all these, ideally it should be 1. So 0.3% and 0.7%, 1%, and 69.3 and 29.7 again is 99%. Yeah. So you are correct. So one way to validate your calculation is just add up all the probabilities. Ideally it should be 1. Now, what you have been asked is probability of bond actually defaulting, given that analyst has already predicted that it would default. So mathematically, this is equal to joint probability of default and analyst actually predicting it to be default over total probability where analyst had predicted. So this is a key point. Understand this. I'll explain it in the next step. So all the scenarios where analyst had predicted that, I mean, outcome was default when analyst had predicted. So the probability of default and analyst also, so model also predicted that it would default. So this is a probability. Model also was accurate and it predicted default and it actually turned out to be defaulted. So it is 0.7%. Now be very careful. Now this is a scenario wherein you have to capture all the possibilities where model turned out to be, I mean overall it turned out to be default. So given that analyst had predicted the default, so that's what if you look at this information, given that model predicted that bond will default, we have to find this complete probability. So given that model has predicted that it will default, so when it can happen, it can happen when analyst predicted default and it actually turned out default. So this is one of the component. So 0.7%. And very important thing, now understand that there is another scenario wherein so if you look at this scenario, in this it is model is not accurate. Okay, so your when you say there would be no default, actually you end up getting default. So that information you have to factor it correctly. If you look at this says model is not accurate. Model is not accurate, and it is saying that it will not default. What it means that you model has given, I mean you have been given that model is not accurate, and it is saying that there will be no default. So ideally, because your model is not correct and it is saying there will be no default, you will end up having the default. So probability of that, so your analyst prediction can come out of via this also. Default can come via analyst predicted default. I mean, model was accurate and default was predicted, and you end up having the default. And another possibility is that model was not accurate and you predicted the survival, but you end up getting a default. So that's the probability. It would be 29.7%. Let's calculate this 0.7%, and this would be how much? It would be say 30.4%. Let's divide these two. 0.7% divided by 0.304. So it comes around 2.3026. I mean, there are decimals, but it is approximately this. The probability of default, given that model has predicted that default will happen, the probability of that is 2.3%. So this is a key information that you have to factor in, that model is not accurate, and when model is not accurate, it is predicting a survival, you end up getting a default. That the probability of that is 29.7%. And so these are the two so in the Bayesian formula, in a denominator you have the exhausted event in the denominator. So for this two, this is a tricky part. Usually that this is a test area. How do you model the situation? Otherwise, you will know the complete process how to solve it. But yeah, this is something which you have to factor. So let's have a look at the options. So looking at the option, it confirms that your option C is a correct answer. Hope you like the video, and I mean, very important from the exam point of view, again reiterating it. So please do share with your friends who are preparing for FRM exam. Thank you for watching. Stay connected. Thank you.